Depending on where you took your algebra courses, you may or may not have covered vocabulary and symbols regarding sets. So we're going to spend a little bit of time on that. In R1, we're going to cover sets. Basically, when we talk about a set, it's just a collection of objects. So a set is a container that we put our objects into. Now, in mathematics, our sets are often sets of numbers, like the integers or the natural numbers, and so on. But basically, in general, a set is just any collection of objects. And the objects themselves we call elements or members of our set. To indicate that we have a set, we use these braces. Sometimes people call them curly braces. This will indicate that we have a set. So that would be our set notation. In example 1, we are asked to list the set of months that start with the letter M. Since we're asked to list a set, we have to use our curly braces, and then that would be March and May. Now, if you can list all the elements of a set, then the order doesn't matter. I could just have easily written May first, and then comma, so we use a comma to separate our elements, and March. Notice that these two sets have the exact same elements. They both have March, they both have May. So we can actually say that these two sets are equal. They have the exact same elements. So order doesn't matter if you can list all the elements, but if you cannot list all the elements, then order does matter because you have to establish a pattern. In example 2, it says list the set, so we know it's a set, of natural numbers. So we talk about the natural numbers, those are counting numbers. It's natural when we count to start with 1. So we have a set that goes 1, and then 2, 3, and so on. Notice that it's impossible for me to list all the elements of the set. So if there is a pattern and I want to indicate that this pattern continues, I would do the 3 dots, which are our ellipses, which means and so on, or the pattern continues, and then close my set. So notice that the order in this case does matter because I'm establishing a pattern. If I had written 3, 1, 2, dot, 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 it wouldn't be clear what the pattern is. Let's move on to some more vocabulary. Whenever we say universal set, later on, and this is the focus of our course, is functions. In pre-calculus, it's the focus of elementary functions. So later on, when we talk about the universal set with respect to functions, we will call it a domain. So the universal set is just all the elements that are under consideration, or all the elements that we can choose from. And a special set is called the empty set, often called the null set. That would be a set with nothing in it. So it's just an empty container. There are 2 symbols for the empty set. The first one would be this 0 with a slash through it. Or you can just use your set braces and have nothing inside it. You have to be careful because on my lab, when you do your exercises, if the answer is the number 0 and you have the option to choose the 0 with a slash through it, then that would mean that you're saying that the answer is the empty set and you may be marked incorrect. So just be careful that you don't write the 0 with a slash through it when you actually mean the number 0. Now there's 2 words in mathematics. We use inclusive and exclusive. So inclusive just means it includes the elements. Exclusive means it excludes elements, or they don't belong. In example 3, we want to list the set of positive numbers less than 0. So again, since we're going to find a set, I'm going to start with my set braces, and now I'm going to list all the positive numbers that are less than 0. Well, there are no positive numbers less than 0, so I would simply close my set braces to indicate that this is an empty set. I could also use the empty set notation. Example 4 says to list the set of letters of the alphabet between A and E, inclusive. And then what about exclusive? So again, we're trying to find a set. And these are the set of the alphabet between, and notice that that's an uppercase or capital A and an uppercase E. So in mathematics, oftentimes, unless stated otherwise, the way you're given the problem is the way you answer the problem. So if we're given uppercase letters, then when we write our set, we're going to use uppercase letters. So if our set is A and E inclusive, it means it's going to include A and E. I would write A, B, C, D, E. So that would be my set. Well, what happens if we're looking about exclusive? So exclusive just means we're going to exclude A and E. So if it's exclusive, it would be the set B, C, and D. So just be aware of the language that's being used. Oftentimes people want to rush through these and they don't read the question carefully. In example 5, it says, what is the universal set in example 1? Let's go back to example 1. In example 1, we were asked to list the set of months that start with the letter M. So what we were choosing from is the set of months. So that would be our universal set. Notice that I couldn't put anything in the set that was not a month in our calendar year. It wouldn't belong in the set. So again, the universal set is the set of all elements that are under consideration. Another way to say that is the set of all elements that you can choose from. It's our domain. So what is the universal set in example 1? That would just be the set of all months. Now this is the English language. So oftentimes there are many ways to describe the same set. You will usually get a choice on MyLab, and maybe the way that you would have worded it may be a little bit different than the way they worded it, but just know that there are many ways to describe the same set. Let's add on to our symbols. A symbol you may not have seen is this weird looking E. So that translates to is an element of. And then the E with a slash, it makes sense to say that that means is not an element of. There's two types of sets. There's a finite set and an infinite set. Finite sets just means that we can count the number of elements in the set. So it'd be the number of elements is either 0 or a natural number. So that the empty set would be finite. It has 0 elements, right? But when you think about the natural numbers, is that infinite? Is that finite? Can we count all the natural numbers? So if it's not finite, it's infinite. And the definition is just, it's not finite. It means we can't count all the elements. In example 6, we just want to answer true or false. A says 0 is an element of the natural numbers. Okay. Now, why do I know that n means natural numbers? Well, oftentimes you will see certain letters that are used to label a set. Since we use the natural numbers so often, whenever you see that capital N, you can assume, unless stated otherwise, that it is the set of natural numbers 1, 2, 3, and so on. So is 0 an element of the set of natural numbers? No, it's not. So the statement is false, right? Because 0 is not an element of the natural numbers. What about B? Kaneohe is not an element of the set of cities in Alaska. Is that statement true? Or is it false? Well, the statement is true because Kaneohe is not. a city in Alaska. So yeah, this statement is true. C, the set of natural numbers less than 5 is an infinite set. Set of natural numbers less than 5, that would be the set 1, 2, 3, 4. I can count those elements, so this is false. And that's because there's 4 elements in the set of natural numbers less than 5. So it's finite. D, the set of natural numbers is an infinite set. That's true. It's an infinite set. Okay, so let's move on to some more notation that you may see as we go through our material in this course. This first weird looking, I don't know, horseshoe, what is this? This is the symbol for subset. And a subset is easiest to describe by looking at 2 sets. So let's say I have set A and set B. This first part reads A is a subset of B, which means that all elements of A are elements of B. That means that everything in A is in B. And the order here matters when you read it. Notice that this symbol is similar to a less than or equal to. So that's kind of saying A can be smaller than or equal to B, okay, but it can't be larger. So order that you read matters here. And then when we say not a subset, we just put a slash through that symbol. Again, that would be not a subset. So if I write set A is not a subset of set B, that means some elements of A are not elements of B. So there's some stuff in A that's not in B. Example 7, we have a set A, which would be the set 1, 3. B is 1, 3, 5. So answer true or false. A is not a subset of B. Is that statement true or is that statement false? Well, everything in A is in B. So A is a subset of B. So that statement is false. A is a subset of B. Part B. B is a subset of A. Well, order matters here. Is everything in B also in A? And the answer is no. The element 5 is in B, but 5 is not in A. So this is false. And C, B is a subset of B. Is everything in B in B? Yes. So every set is a subset of itself. Well, actually, except for the empty set. So this would be true. Let's add on to this. In fact, let me make a note here. And this is about the empty set. In general, the empty set is a subset of all sets because there's nothing in it. So everything in the empty set is clearly in the other set. So we agree that the empty set is a subset of all sets except itself. All right, so let's move on to add in more symbols. These next few are really important. And this weird looking U, hopefully you've seen this. This is what we call our union. And this is where we union sets together. When you union sets together, you're putting them together to make one big set. Sometimes instead of seeing that symbol, you will have the word or. And we'll look at an example of that in just a little bit. So again, the union just means that you're going to combine the elements of all the sets and make one big set. If you flip that U, it kind of looks like an N, and that's because this is an intersection. So union looks like a U, flip it, you've got the intersection. The intersection of sets would be the elements that are common to the sets. Sometimes instead of using that symbol, we'll use the word and. So it would have to be in this set and in that set and in that set and so on. So again, that would be elements common to all sets in our intersection. And then there is a symbol that is not used very often, and this would be this apostrophe here, or the accent mark. That little tiny mark is called the complement. So I put an A, a set A in front of it. So this would be the complement of set A. That's how I would read this. And now when we say complement, that's like a subtraction. What you're going to do is you're going to take your set and you're going to subtract it from the universal set. The complement is what's left over. So that would mean all elements that are in the universal set but are not in the set itself. Let's practice some of that. And now you won't be using the complement in this course, but you may see that symbol even though you're not required or you're not tested on that. In example 8, we have a universal set 1, 2, 3, and then there's a comma, and I wanted to show you another use for the ellipses. Notice that there's a 3 dots. It means the pattern is going to continue, so and so on. But this set's going to end. It's not going to go on forever. So since it's not going on forever, we're going to do another comma after the 3 dots and put in the last element. So this is the set 1, 2, 3 through 10. Now I could have just as easily listed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but I wanted to show you another use for the 3 dots. That's our universal set. And then we have these subsets of our universal set. We have set A, which is the set 1, 3, B is 1, 5, 10, and C is 2, 4, 6, 8. We want to find the following. Part A, C complement. So C complement is going to be a set. It's going to be the set of everything in U that's not in C. So we're going to take C away from U. What would be left over is 1, 3, 5, 7, 9, 10. Again, I didn't have to list it in the order from smallest to largest, but it was just natural for me to do that. I could have rearranged this and it would still be the same set because I can list all the elements. So again, 1, 3, 5, 7, 9, 10, those are elements in the universal set U that are not in C. Part B, we want the intersection of set A with set B, so that's going to be a set. Set A is 1, 3, B is 1, 5, 10. So remember, the intersection are what these two sets have in common. It looks like they both have 1, and that's it. So I'm going to close my set. This would be the intersection. Part C, we want to find the union of B with C. So again, it's going to be a set. Union means just put these all together and make one big set. So I have 1, 2, 4, 5, 6, 8, and 10. Let's see, did I get them all? Again, order doesn't matter. I could have written 1, 5, 10, 2, 4, 6, 8. Okay, that's it. In D, we want to have the intersection of B with C. So intersection again is what they have in common. If we go back up to B and C, it looks like they have nothing in common. So I'm just going to close my braces to indicate that this is the empty set. And now look at a question in words. This will not be on my lab, but it's really good for you to practice with ors and ands, since that may come up later. E says the set of elements in A or C. And again, that word or is important. Or means we're going to make a big set with the elements that are in A, or we can also use elements in C. So we're talking a union. Okay, remember, or is union. So the, oops, and that was C, sorry, I wrote B. So the union would be putting these two sets together. Going back up, A is 1, 3, C is 2, 4, 6, 8. So their union would be 1, 2, 3, 4, 6, 8. Again, I could list all the elements, so the order really didn't matter. The last question would be to list the set of elements in A and C. So these are elements that are in A and also in C, which would be an intersection. So I could write this as the intersection of A and C. What do A and C have in common? Nothing. So that would be the empty set. This is the end of R1, and that's it.